In the last couple of videos, we've been looking at if you know the angle, how do you figure out the sides of the triangle? Well, now we're going to be doing this process backwards. We're going to say if you have the sides, can you figure out what the angle is? And we're going to start with very simple angles. We're only going to use the 30, 45, and 60 to begin here. So here are some trig values that you're going to end up memorizing. It'll be very helpful. Eventually, we're going to know a lot more than this, but it'll be very helpful just to get these down for the time being. And you'll see it's a lot of the same numbers repeated over and over again. For example, both the sine and cosine columns have 1/2, and a square root of 2 over 2, and a square root of 3 over 2. It just flips the order that they are given to you. And then tangent has slightly different numbers on its own. And you'll see that when we fill in the rest of the unit circle as well, that it's a lot of the same numbers repeated over and over and over again. So what you're going to be doing is looking at which trig function you were given in the question. If it was a sine, cosine, or tangent question, that's how you would identify which of these columns to be looking at. Then you're going to look for the specific ratio based on the sides that they gave you. If your sine function has the opposite side and hypotenuse being equal to 1 over 2, then I would recognize that this, in the sine column, this is the value I'm interested in, so the angle must have been 30 degrees. So that's how you'll determine the angle. You'll be combining the information for which trig function they gave you and what the relationship to the sides is to figure out the theta value. So here are 3 quick examples where we are being asked to find the theta value, which is the angle, and we're being given the relationship to the sides. So I know that for cosine, that means this is the adjacent side and the hypotenuse. That's the ratio between the two of them. I want to figure out what the angle must be to create this. So I'm going to look back at the previous slide. Since it was the cosine function, I'm looking at the cosine column. Ignore the other 2 columns on the outsides. So here's my cosine column. And then since the value was equal to 1/2, here is 1/2 in the cosine column. So the angle that's associated with that is 60 degrees. So over here, I'm just going to specify that theta equals 60 degrees. Now, some questions will ask you to specify the answer in degree measurements. Sometimes they will ask you to do it in radians. So for these directions, I just went ahead and said show both, but always pay attention to the directions. Usually they just want one or the other. So I'm also going to take this angle measurement and I'm going to do the conversion to get it back into radian form. So if I wanted to change 60 into radians, I would do 60 degrees times pi over 180. And I'm putting the 180 degrees in the bottom for this fraction because that would make the degree symbols cancel. Well, 60 over 180 can be reduced, so the other value for theta in radian form would be equal to pi over 3. So these are both answers to the statement cosine of theta equals 1/2. Either theta equals 60 degrees or theta equals pi over 3. So now for the next example, I have tangent of theta equals 1. So I'm going to go back to the previous slide, look at the tangent column, and find where it equals 1. Here are the values I'm asking you guys to memorize for now. So here's the tangent column. Here's where tangent equals 1. And that means the angle associated with that is 45 degrees. So I'm going to write theta equals 45 degrees. So that's one part of my answer, but they also want the answer in radians. So again, I'm going to convert this. If I take 45 degrees and I multiply this by pi over 180, that's that process of converting between degrees and radians we looked at earlier, then the other form of my answer, since 45 over 180 reduces to pi over 4, that's my other answer. So here's the answer in radian mode, here's the answer in degree mode. So one last quick example. This one has cosecant of theta equals 2, and you may have noticed that I didn't have the cosecant, secant, and cotangent values on that little table. So let's look at how to approach this answer. So what you need to remember is that cosecant of theta is the reciprocal of sine, so it equals 1 over sine of theta. So make sure you know which functions are reciprocals of each other. So in this case, by getting the cosecant function, I'm still going to be looking at the sine column. I just need to think of these answers that are shown here, and I need to flip them upside down. So the answer they showed was 2, which is 2 over 1. Well, the fraction that would end up being 2 over 1, if I flipped it upside down, would be this 1/2 one. One word of caution on this is if you don't see your answer, make sure you consider that you have to rationalize these other 2 values. So if you had 2 over root 2, rationalize it for flipping it upside down, because otherwise you might not recognize that it's the same number they've given you. So in this particular question, when cosecant equals 2, that means sine equals 1/2. So my angle is 30 degrees for this one. So theta equals 30 degrees. And then again, for converting this quickly to the radian mode, you'll start to memorize these the more you do them. If I do 30 times pi over 180, then all I need to do is reduce that 30 over 180 part. The zeros cancel, so 3 over 18 is equal to 1/6. So pi over 6 would be the radian form. For this next part, I'm not going to be using the easy 30, 45, and 60 degree angles. We're going to look at some other uglier angles, but you'll be wanting to use your calculator to evaluate those. You don't want to try and do like sine of 37 degrees without a calculator, for example. So the important thing to do on this is look at what information they've given you in the triangle. So starting from the angle you have, identify which sides you know in terms of the adjacent, opposite, and hypotenuse. Once you figure out which sides you have, that should help you identify which trig function to use. For example, if they've given you the opposite side and the hypotenuse, you should use sine, because that's what sine gives you. For SOHCAHTOA, sine gives you the opposite over hypotenuse for your answer. If it's the adjacent side and the hypotenuse, use cosine. If it's the opposite and the adjacent side, sine, then use tangent. So once you figure out which trig function to use, you're going to write an equation using the angle and that relationship between the two given sides. And then one of those three values should be missing, so solve the equation, just like in algebra. Use your opposite operations to solve the equation. So 2 examples for this. Here's my angle up here in the top left. And if I were to label the 3 sides I have here, well, this side is the opposite, and I don't know what that value is, so I'm not going to use it. This side here is the hypotenuse. That's one of the ones they've filled in for me. So I want to use something that has hypotenuse in the trig function. And this side over here that they've given me is the adjacent side. So I know I'm going to be using 37 degrees. And out of my options for functions that have adjacent and hypotenuse, the easiest one to use would be cosine, because going back to the SOHCAHTOA information, cosine has adjacent and hypotenuse. You could also use secant, and there might be some cases where this is advantageous, especially if it lets you avoid having to do any rationalizing. So you may also be tempted to use secant, but for the most part, you'll probably just want to stick with the simpler ones to compute, the cosine values. So I'm going to write cosine of 37 degrees. That's the trig function I'm picking based on the relationship to the sides I have here. And the rule for cosine was adjacent over hypotenuse. So this is the equation I've written. Using the 3 numbers they gave me, technically 2 numbers and a variable, now I have something that I can solve for. I can solve for this x. My first step here would be to multiply both sides of the equation by x. So that would give me x times cosine of 37 degrees. And then that would equal 11. So my last step would be to have x equals, I would take the 11 and divide it by cosine of 37. That's how I would move that value to the other side of the equation. So you can't do this by hand. This is something that you need a calculator for. So in your calculator, hit 11 divided by cosine of 37. And be careful, make sure you're in the degree mode for this one, because my angle was in terms of degrees. If you have it in radian mode, you will get the wrong answer here. Always pay attention to the directions too for specifying what you should be rounding to. A good standard, if they don't say, is just to go to 3 decimal places. So I'm going to write 17 or 13.773. And so now here's a second example real quick. Again, I have an angle, 41 degrees. To determine which trig function I should be using for this, I need to recognize that this is the opposite side and this is the adjacent side. So I could either use tangent or cotangent. It doesn't matter which one. So if I use tangent of 41, well, the rule for tangent of an angle is that it's opposite over adjacent. So for solving my equation, I'm going to multiply both sides by x. And then I need to get the x by itself, so the opposite of multiplying by tangent of 41 is dividing by tangent of 41. So in the calculator, I'll be typing in 4 divided by tangent of 41 degrees. And for that answer, again, make sure you're still in degree mode because my angle is still in degrees. If I round this to 3 decimal places, I would have 4.601. Here's a word problem because I know you guys are still struggling with how to draw the diagrams and set up the equations based on a scenario like this. So really, you just want to be able to draw a diagram. We know that we're dealing with triangles, so I'm going to go ahead and draw a triangle here. And then basically what's happening is we have a building. You don't have to draw this in. I'm just doing this for reference so that hopefully the equation I set up will make more sense. So you can imagine a building here, and then there's a guy up on the roof of it looking down. And then there's another person down on the ground looking up at him. She has bow and arrow. So Katniss, which is the person down here, it says she's 340 feet away from the base of the building. So from her to the base of the building, that means the bottom of the building, is 340 feet. So that's a number that I can write in for a distance from the person to the building, but not up to the top, and not the height of the building, but from her to the bottom of the building. Next, they mention an angle of elevation. Well, it says angle, so I'm pretty sure that's one of the values inside of the triangle. And I know that this should be a right angle. I can fill that in, not even based on the word problem, just if you take a 90-degree turn up to go vertically, that would be 90 degrees. But an angle of elevation, which is something we'll look at in more depth later, that just means how far are you looking up to see an object up above you. So that's the angle down here for reference. And that's a concept we'll explore more actually fairly soon in this class. So for now, just understand that an angle of elevation means the angle to look up at something in the distance. And so we have a person set on our bench here. She wants to know from the base of the building, how high up is the person? So that's one of the questions we're asked. And the second part of the question is, what's the distance the arrow would have to travel? Well, the arrow is not going to go over and up. It's going to go directly diagonally to the person. So basically, they want us to find the two missing sides of this triangle. Well, I have an angle and I have a side here. So I'm going to solve for the first question they asked me for, the distance from the base of the building up to the target. That would be the height of the building. So from my angle, that would be the opposite side. I also know the adjacent side in terms of my angle. So this would be a good case to use tangent on. So I would say tangent of 65 degrees is equal to opposite, I'm going to call that value y since it's vertical, over adjacent, which is 340. Now, if I want to solve this equation, all I have to do is multiply both sides by 340. And again, please make sure your calculator is still in degree mode. So I'm going to do 340 times tangent of 65 degrees. And my height comes out to approximately 729.132. So again, just kind of a good standard is to go to 3 decimal places. Now, the other piece they asked for was the diagonal part, and you actually have two options here. Now that I know two sides of this right triangle, I could actually switch to using the Pythagorean theorem, but I want us to keep practicing with the SOHCAHTOA rules. So I'm going to go back to the pieces of information I was given originally, so it'll be more precise than going to the one I had to round off. So I have my angle, I have my adjacent side, now I want to know the hypotenuse. So for this setup, it would be good to use the function cosine, because cosine relates the adjacent side to the hypotenuse. So now it's cosine of 65 equals adjacent, 340, over my hypotenuse, so I'll call that h. So multiply both sides by h. So h times cosine of 65 degrees will equal 340. And then divide both sides by the cosine of 65. So in my calculator, I'm going to hit 340 divided by cosine of 65. And that gave me the hypotenuse of 804.509. So they had asked me for two different things here. The distance from the base of the building up to her target, from the base of the building up to the target, that was this answer. And for the distance the arrow will travel, that's the direct diagonal distance. That's the 804.509. So it's the same concept. We just had to draw the diagram ourselves, fill in as much detail as you want to help you figure out where to put each side of where to put each number for the sides of the triangle or the angles. And that's it for the notes today. Thank you.